In this video, we're going to be talking about the OSI model. It's a framework that explains how data travels across networks. Specifically, we'll be exploring layers 1 through 4 in this video, and in the next video, we'll be talking about layers 5 through 7. Now, this video builds on my previous videos, so make sure to check all of them out. So, the purpose of the OSI model is it's like a framework that outlines the plan on how data should be traveling between networks. Imagine if you had to walk a file across the room on a USB stick every time you wanted to send something. Thankfully, networking automates this process. But for communication to work, devices need to follow a shared set of rules. Just like how languages like English or Spanish have grammar syntax, the OSI model organizes these rules into 7 layers. These 7 layers, each with their own unique rules in the process. So let's start with layer 1. So this layer is like the foundational layer of the OSI model. This is where it's used for the communication and responsible for the moving of the bits, the zeros and ones between devices. As the name suggests, it's physically how the device communicates. So it uses cables, Ethernet, it uses fiber optics, or even uses wireless signals like Wi-Fi. They all count as layer 1 technologies as they transport raw data. Think of it like the roads of just streets, just roads. Like you need for a car or like a truck or a mail carrier to travel, it needs the road to travel. So these are like the roads so the data can be sent over. This is the data link layer. This is where the rules are set up for how the data is to be exchanged between two devices. Now this layer uses network interface cards with these things. So network interface card is like a translator or like a messenger for your computer when it needs to talk to other devices. It connects to your computer to the network, either with a cable or like a wireless option like Wi-Fi. This is probably the most important component as a device cannot communicate to another device without this. It is in every device, your phone, your computer, your laptop, or even in your AirPods. It uses MAC addresses to communicate. Now think of it this way. The physical layer 1, is the road itself. Layer 2 is the mail carrier itself. It's the thing that's actually used to transport data. Now a mail carrier or like a mailman, whenever it is sending the mail or like delivering the mail, it will check the address of the home to make sure it ends up on the right home. Similarly, we use, in a computer world, networking terms, we use a switch. Switch makes sure that the data ends up on the right computer or the right device. And for this it uses MAC addresses. Now this is the network layer. This focuses on the end-to-end delivery. So layer 2 just focuses on sending the information just within its network, whereas in layer 3 it makes sure that the data can be sent anywhere. So it can be sent from here in New York to all the way in Tokyo or Japan. So it makes sure so there's no limitations to where the data can go. And for it to be able to be sent between networks, it needs IP addresses. This is where routers come into play, because routers are used to transfer data between networks. So this is the layer 4, or the transport layer. So layer 3 will make sure that the data ends up in the right city. I'm using an analogy over here. So layer 3 will make sure that the data ends up in the right city. Layer 2 will make sure that it ends up into the right building. Now this is where layer 4 comes in. Layer 4 will make sure that it ends up on the right floor, and it makes sure that it ends up on the right office space. It makes sure that it ends up on the right desk. It gets very specific, it's making sure where the data has to be sent. It uses port numbers for to be able to send it to a specific desk. Now, in networking terms, it makes sure in networking terms, a computer receives like tons and tons of data. Layer 4 will make sure that the right data goes to the right application. So it makes sure that the gaming data goes to the game, the web data goes to the web browser, and the messaging data goes to the messaging application. Now for layer 4 to be able to send this data to a specific application, it uses two protocols, TCP and UDP. TCP, or the Transmission Control Protocol, this is when sending data between devices, it makes sure that data is checked, make sure its integrity is still there, like it's not ruined or it's not corrupted, and make sure that the data is actually received by the destination computer. And so it's a very secure, and make sure like the data actually ends up. Whereas usually because it has so many steps, it will usually take a little longer. Whereas UDP is, on the other hand, is the fast one. It makes sure that the data ends up as soon as possible. But because it's doing this, it sometimes skips some of the checks and makes safety precautions so that the data ends up faster and ends up at the location faster. So apps like video calls or gaming, they will often use UDP because of their speed. Now for games and video call, you need instant interactions. You're needing fast data transfers. For that reasons, we're going to be using UDP. Whereas TCP will be used for mail transfers or like file transfers. In those applications, they need to make sure that the data is accurate and it's not corrupted while it's getting transferred. So for those reasons, they will use TCP. Whereas if you need a fast data transfer, they will use UDP. Now, together, these layers make a powerful stack. So let's recap. Layer 1 it's like the physical layer. It makes sure that it moves bits, the zeros and ones. Layer 2 makes sure that it ends up on the right computer. Layer 3 makes sure it ends up on the right network. Layer 4 makes sure it ends up on the right application, make sure the data is intact and it's not corrupted or broken. Now each layer depends on one another, and understanding this hierarchy is the key to mastering networking. Now for this video, I'm just going to end the video right here. In the next video, we'll be talking about layers 5, 6, 7. This is usually where all the software related parts happen. Catch you in the next one.